Yeah, I started recording. Okay, so here, dear students, as I told that the temperature is the measure of degree of hotness or the coldness of the body, and there are three ways of measuring, that is degree Celsius scale and degree Fahrenheit scale and a Kelvin scale. Okay, in that the first one is a degree Celsius scale that we mainly are dependent on. Where the 0 degree Celsius is the melting point of the water and 100 degree Celsius is the boiling point of the water, and it is calibrated between that. Okay, so it contains 100 value in between that, right? And also the symbol used for this one, okay, the symbol used for this one is whenever you're writing the value, you have to write in degrees Celsius in this way. For example, if I want to record a value of a hotness which is 25 degrees Celsius, I have to write in this way. Okay, I have to write in this way. So the reading of this one will be now 25 degrees Celsius, and we consider this as a normal room temperature. Okay, even though we know that the room temperature, okay, room temperature that is not exactly 25. Now we feel even if it is raining outside also, we usually don't experience that one, but we still consider in our chemistry term, we normally when we talk about room temperature, we feel that it's a 25 degrees Celsius, a standard one. Okay, a standard one, we consider it is a 25 degrees Celsius. Got it? So reading is 25 degrees Celsius, right? And there are some values, the common values. For example, human body value is around 37 degrees Celsius. Okay, 37 degrees Celsius. The human body temperature is around 37 degrees Celsius. Got it? We should not go beyond that one, or it should not fall below that one, and we'll feel sick. Okay, we'll feel sick if it is falling even below this or above this, right? Will feel sick. If it is beyond too much value, then definitely we are in problem. Okay, if it is going too much away, okay, the value, then definitely the human is going to die. Got it? So therefore this is the degree Celsius scale where boiling point and melting point is measured in this way. Got it? So there are some other scale also, that is, why do we use degrees? It is just a way of writing this one. Okay, writing this one. And also the degree Celsius and the degree Fahrenheit is used only for the degree Celsius and the Fahrenheit scale. Okay, for Kelvin we are not using it. For Kelvin we are using only the symbol. We'll be using the symbols like K. Okay, there is no degrees used here. So it is used mainly for the Celsius scale and the Fahrenheit scale. Okay. Just a minute, I'll admit the one who's joining now. Okay, so as I was telling that the Fahrenheit scale is a scale which is mainly used, okay, in the US. Okay, in the US they will be mainly using this one. They'll be measuring the temperature in the Fahrenheit only. Okay, now slowly the usage has been reduced because we feel, okay, we are more adjusted to the degree Celsius scale only, or the Celsius scale only, but still we can use it. And here the boiling point and the melting point, sorry, I can write the melting point first. Melting point and the boiling point is adjusted between the value that is 32 degree Fahrenheit to 212 degree Fahrenheit, and if you see the difference between them, it is 180 degree Fahrenheit. Okay, 180 degree Fahrenheit. So I think it's going out of the board, right? So let me just stop here. So this line I won't cross. Okay, so whatever the things that I'm writing now here, I'll write somewhere over here. Okay, I will write somewhere over here. Just a minute. Okay, I'll admit. As I was telling that the degree Fahrenheit, just a minute. So the degree Fahrenheit scale lies in between the value that is boiling point is taken as 32 degree Fahrenheit, and the melting point is taken as this one, and boiling point is taken as 212 degree Fahrenheit. Okay, if you see the difference between them, it is 180 degree Fahrenheit. So what it indicates is, for every 1 degree, okay, for every 1 degree rise in the degree Celsius, there is 1.8. Reason is because degree Fahrenheit, the boiling point and the melting point difference is 180, whereas in the degree Celsius scale, the value of difference between them is 100. So what it indicates is, for every 1 degree rise in the degree Celsius scale, there is 1.8 times rise in the degree Fahrenheit scale. Okay, for 1 degree rise, for 1 degree increase in the temperature in the degree Celsius scale, there is a rise of 1.8 times of the value for the degree Fahrenheit scale. So therefore, if you want to relate these two, Fahrenheit scale and the degree Celsius scale, we have to write a formula between that which relates in this way, that Fahrenheit scale, okay, for the Fahrenheit scale, the degree Celsius scale increases by 1.8 times, okay, for 1.8 times. 1.8 could be written, okay, as 9 by 5 also, okay. So therefore, if you want to convert the degree Celsius into the Fahrenheit scale, what you need to do is, you have to multiply it by 1.8 times. That is nothing but 9 by 5, because 9 by 5 is also 1.8 only. For example, if you multiply this by 2, this by 2, it becomes 18 by 10. 18 by 10 is 1.8 only. But only thing is, you should add the value, that is 32 degree Fahrenheit. The reason for that one is, if you want to calculate for 0, okay, see, if the melting point of water is 0 degrees Celsius, if you want to convert into the Fahrenheit, it should come out to be 32. If I don't consider this 32, what happens here is, for example, if I substitute this as 0, 0 into 9 by 5 is 0. So Fahrenheit comes to be 0 only. Okay, that is not true, because the Fahrenheit and the degree Celsius is melting point value, it starts from the 32. Got it? It means I just need to add this 32 to make it equal to the 0. Got it? So understand that for 1 degree rise in the degree Celsius, there is an increase of 1.8 times. So therefore, Fahrenheit will be 1.8 times of degree Celsius, plus for the value of 0, you just need to add the 32. So this is the relation. Okay, that's the relation. Or if in a proper way, if you want to write, it would be like degree Fahrenheit. Okay, degree Fahrenheit is equal to 9 by 5 into degree Celsius plus 32. Okay, this is the relation. Or if you want to write it in terms of the degree Celsius, okay, degree Celsius, it would be like this. See, I'll take the 30 to this side. It becomes F Fahrenheit minus 32. See, I'll show you how it is calculated for the degree Celsius. It would be like this. So I'll be bringing the 32 to this side. It becomes degree Fahrenheit minus 32 will be equal to 9 by 5 into degree Celsius. What I've done, I've taken the 32 this side, it becomes minus 32. Now in cross multiply, 5 will be multiplied to the numerator, 9 comes to the denominator. It becomes 5 by 9 into degree Fahrenheit minus 32. That is nothing but degree Celsius. See, this is our one more scale. So I'll write here 5 by 9 into degree Fahrenheit minus 32. Got it? Okay. Which part you didn't understand? Which part you didn't understand, Ganesh? You can just come out with the reply that I didn't understand this one. It's a scale, okay? Understand that it's a scale that we have taken in this way. For Fahrenheit, we have to start with 32. After Fahrenheit means this formula, how you got the formula, I will explain that formula part once again, okay? If any problem, if any part you are not understanding, you can message. So see, I'll tell you slowly now, okay? I'll tell you slowly. See, what happens here is the degree Celsius scale, okay? The degree Celsius scale, if it is in this way, okay? Imagine it's a thermometer now, and we are measuring in the degree Celsius. So when it was inserted, okay, when it was inserted in the ice cubes, okay, ice cubes, or imagine this is maintained at 0 degrees, which is at the boiling point, or sorry, the melting point, okay. Now when we measure, okay, no, exactly it is not 1 degree Celsius equal to 1.8. It increases by that value, okay, it increases by that value. See, when we measure, okay, when we measured by the degree Celsius scale, what we found is when it was started to melt, okay, when it was started to melt, the value stopped exactly at 0 degrees Celsius. Okay, at 0 degrees Celsius. Now we started to heat it. Okay, I'll explain this in a different way now. Okay, I'll explain now. So when I started to heat this one, slowly this started to melt, and it has melted, and it slowly started to become liquid, and it has become liquid now. Slowly the temperature is increasing from 10, 20, 30, 40, 50, 60, 70, 80, 90, 99, and when it is exactly reached to 100 degrees Celsius, what we saw is all the liquid water, pure water started vaporizing. So I can tell you that now this is a boiling point. So when I measured it, I found that it is 0 degrees Celsius and 100 degrees Celsius. Okay, so therefore we marked this one as a 0 and we marked this one as a 100. So we can see that the melting point of water is 0 degrees Celsius in Celsius scale, and 100 degrees Celsius will be the boiling point in the Celsius scale. So after that, what we have done here is the same set. Okay, the same set, that is ice cube, the ice cube, and now there is a temperature scale. Okay, the thermometer is inserted, and this thermometer is measuring in the Fahrenheit scale, and when it has started to melt slowly, that is called as the melting point. In the Fahrenheit scale, it was measured as 32 degree Fahrenheit. Okay, what it indicates is 0 degrees Celsius is nothing but 32 degree Fahrenheit. Okay, Fahrenheit. Now when they started to heat, okay, when they started to heat this one now, so again, so same set I repeated. When started to heat this one now, when started to heat this one, slowly the Fahrenheit scale increased to 70, 80, 100, 120, 140, 150, 170, 180, exactly at 2 degree Fahrenheit, it started to boiling. Okay, so in the degree Fahrenheit, 32 degree Fahrenheit is the melting point, and 212 is the Fahrenheit is the boiling point. Okay, so what we got finally here is the degree Fahrenheit boiling point and the melting point difference is 180 degree Fahrenheit, whereas the boiling point and the melting point difference in the degree Celsius scale is 100 degrees Celsius. So what it indicates, for every 100 degree rise, there is a rise of 180 degree in the Fahrenheit scale. For every 10 degree rise, there is 18 degree increase in the Fahrenheit scale. For 1 degree rise, there is a 1.8 times the increase in the Fahrenheit scale. So therefore, if you want to relate the degree Celsius with the degree Fahrenheit, it should be degree Fahrenheit should be 1.8 times. But at the 0 degree Celsius, it has started at 32. So I just need to add the 32. So I got the formula as degree Celsius will be equal to 1.8 times of degree Fahrenheit plus 32. Okay. 1.8 you can either keep it in this way, or you can make it as 18 by 10. Okay. 18 by 10 is also, because for the calculation, simply calculating term, we can use in this way. Then 1.8 or 18 by 10 can be cancelled as 9 by 5. Common term is 2. Okay, so therefore the formula becomes degree Fahrenheit. If 1 degree increase, then it is equal to the increase of 1.8. Yes, almost to that only. Plus 32 value you should add. Okay, it's but almost it is increased by 1.8 times only. Once repeat what you're told. What I told is, for every 100 degree rise, there is a 180 degree Fahrenheit rise in the Fahrenheit scale. For every 10 degree rise, there is 18 degree Fahrenheit rise in the Fahrenheit scale. For 1 degree rise, there is a 1.8 degree Fahrenheit increase in the Fahrenheit scale. It means degree Celsius and Fahrenheit are related to degree Celsius equal to 1.8 times of Fahrenheit scale. But for the 0 degree Celsius, since Fahrenheit scale starts at 32, you just need to add that value over here. Okay, you just need to add that value. So as you have only told, for 1 degree rise, there is 1.8 times the increase in the Fahrenheit scale. Got it? For 1.8 times the increase in the Fahrenheit scale. Got it? If you substitute 100 also, you know, if I substitute the degree Celsius, I just got it wrong here. It should be reversed. Okay, this should be reversed. For the Fahrenheit, there is 1.8 times the increase in the Celsius scale. Okay, just got it wrong. Okay, just make it as I wrote in reverse. For every Fahrenheit scale, okay, for every 1 degree rise, there is 1.8 times rise in the degree Fahrenheit scale. Okay, so plus 32. Okay, This is with the formula that is written over there also. Okay. Yes, Adarsh. Yes, yes, Pawan. So this is the relation between the degree Celsius and degree Fahrenheit scale, and that you can use for the calculation also. Got it? Okay. Okay, fine. So I hope you are understood. You have understood this one. In that case, I'll tell you to calculate one small thing now. Okay, I'll tell you to calculate one small thing. Can you calculate? Okay, can you calculate uh, what will be the degree Celsius? Okay, what will be the degree Celsius? Just calculate. Okay, just calculate and tell me the answer. What will be the degree Celsius for 0 degree Fahrenheit? What will be the degree Celsius for 0 degree Fahrenheit? Understand, for 32 it was 0. Now if you are going below this one, the value should go below 0. Okay, understand this. Calculate and tell me the answer. Calculate and tell me the answer. What will be the degree Celsius for 0 degree Fahrenheit? No, no, calculate. Yeah, almost close to that, Akshay. Yes, negative answer can come.
You can.
Yes, I got an answer here. Just a minute. Okay, no, many of you are not calculating. You are just answering. You are going wrong. Many of you are wrong here just because you are just telling that. Shilpa, Manjunath, Ritika, and here first Adarsh and Namita. Yes, very good. You people are correct here. Okay, you people are right. It is minus 17.7. Okay, it is not possible. How, Vinata? Why it is not possible? Have you not measured the value below 0 degree Celsius? Have you never heard that the temperature is below 0 degree Celsius? It is possible. It is possible. Prajwal, good. It is minus 17.7. Vinita, have you understood? Many of them are answering. Now it is correct. Okay. Many of you got answer at the beginning. Many of you just directly told that it is minus 32. But understand, I will tell you one simple hint. Okay. I'll tell you one simple hint. Yeah, Namita, it's very cold. But you should tell me the value, right? It is very cold only, very cold temperature. We cannot survive in that temperature until we are completely covered. Okay. Okay, many of you got the answer. Might be you might have used the this one, right? I'll show you. You might have used the formula. Okay, which one? You might have used this one, because degree Fahrenheit is given as 0 degree Fahrenheit and the degree Celsius is asked. So you can calculate in this way: 5 by 9, and this is 0 minus 32, right? So after calculating, so this is how anyhow got cancelled. So minus 5 into 32 divided by 9. So you'll get degree Celsius as minus 17.7. So you might have done in this way. No problem, Rohit. Anyhow, this will be posted in the group, sorry, YouTube. Okay. So you can see the video there. You can clarify your doubt. Okay, students, let's come to this. So as I was telling, you might have used this formula for the calculation, right? Yes, Shilpa. Okay, good. So I'll tell you one simple hint. Okay, just to get the answer, you can do that and you can get the answer very quickly. I told you that for every, okay, just now we told for every 1 degree rise, there is for every 1 degree rise, there is 1.8 times of increase in the Fahrenheit scale, right? Fahrenheit scale. So if you want to get from 32 Fahrenheit to 0 Fahrenheit, you can see the difference is 32. Are you getting my point? If you want to bring from 32, because 32 to 0, I'm told you to calculate at 0 degree Fahrenheit. Okay. So from 32 to 0, okay, from 32 to 0, right? You have to bring it to the 0 Fahrenheit. So the difference is 32 minus 0, that is 32. Got it? 32 divided by 1.8 you do. So you'll get minus 17.7 only. Got it? 32 is the difference. 32 is the difference. Divided by 1.8 you do, you'll get that 17.7 only. Got it? Are you getting my point here? If you want to bring it to bring it the 32 to 0, okay, so just to do 32 divided by 1.8, you will get 1. It will appear in the thermometer only if the thermometer is taken below 0 degrees Celsius. Otherwise there is a different scale that we have to use. Okay, we don't measure all the temperature using the thermometer only. Okay, thermometer is a instrument which is usually used for the calculation in the laboratory or the body temperature. Okay, because we know our body temperature cannot go beyond 33 sorry 34 35, right? Or it cannot go beyond 40 or something. So that's the reason we will be using mainly for the measurement of some of the liquids, some body temperature, just to know the room temperature, because it will not vary that much. Okay, the thermometer, I'm telling, thermometer should not be used for measuring some of the things. Like you cannot use the thermometer for measuring the flames. Okay, you should not flame. There is a one question usually that comes to the mind as it is positive, but you are going in a negative value, right? You are going from 32 to 0 means you are going in a negative. You just take that as a, or you can do it like this: final value is 0 and initial value is minus initial value is 32, so 0 minus 32 divided by 1.22, it comes to be negative only. Mansa, I hope you got what I'm telling here. Finally you are be taking it to 0 value. It was initially 32, so just subtract, divided by 1.8, the difference I'm telling. Okay, what I was telling here is the thermometer cannot be used for measuring all the things that we get. Okay, we use the thermometer to measure flames. That's what I'm telling. You should never use the thermometer to measure the flames temperature. Okay, because flame will be very high temperature and the thermometer may burst out, or you may spoil the thermometer permanently. Okay, so you should not use the thermometer. Understand or remember this: thermometer should not be used for the measuring of the flame. It should be used only for the measuring of a body. That's why for the temperature of a liquid or a body. Got it? It should be used only for the measuring of something, not the flame. Okay, you should not use for this something like liquid. If you're boiling, if you're heating water, use the thermometer. If you want to measure someone's body temperature, use the thermometer. If you want to measure the temperature of a liquid that you are boiling, okay, if you are boiling something and if you want to see the temperature of that one, you can use. And in the laboratory we many times use it. Okay, many times in the laboratory. It may not be used for you people in your laboratory when you come to the PU classes and all. Here in the laboratory we are not using it, but in the laboratory, in our laboratory during our MSNL, we have used it. We used to tie the thermometer to the glass tube and you will be heating the liquid. It tells you the exact temperature that you have to maintain. Got it? So in that case we can use, but you should not be used for the measuring of this flame. Okay, remember this one. So this is how we can calculate or we can convert. No problem, Sana, no problem. The video will be uploaded in the YouTube immediately after the completion of all the PCMB or PCMS classes. You can just go through the YouTube and you can just see the video. Okay, you will come to know. So let's move to the next one now. Let's move to the next one, that is called as a Kelvin scale. Okay, Kelvin scale. It is again given by the Kelvin. So therefore it has been kept with his name only. And here one thing about the Fahrenheit scale or the degree Celsius scale and the Kelvin scale, there is one difference, major difference between all the differences between the Kelvin and the other two is Kelvin scale gives the value. Okay. Yes, Ganesh, you can come to college. Okay, during the college hours between like 10 to 5, you can come at any time if you are free in between that. Okay, or if you want to come early or if you want to come little late, you can inform. We can do some arrangement. Okay, but it would be preferred in between 10 to 5 or even the 9 to 5 is also okay. Okay, so someone's mic is on. The student, whenever you enter the classroom, it's preferred to mute. So better you only mute yourself, otherwise I'll mute. Okay, so just muted everyone. Video is not clear, don't worry, the Vasant, It will be uploaded in the YouTube. You can refer that. Okay. So let's move to the Kelvin scale now. The third type of measurement is used by the Kelvin scale, one of the most important scale, because this measures, okay, this takes the least possible, okay, the least possible temperature that we call as the absolute zero, okay, absolute zero, we call that one as a 0 Kelvin, okay. It starts from the 0 Kelvin. It is minus, what is that, Vinita? It is 273.15 in terms of degrees Celsius, okay. I'll tell you what is that, okay. So it starts from the absolute zero to triple point of water, to the triple point of water, which is 273.15. Triple point of water is almost nothing but melting point of water only. I'll tell you what is exactly absolute zero. We have not achieved, okay, we have not achieved yet. We have not achieved the absolute zero temperature. We have gone to close to that, okay. The scientists have gone almost close to that one, but we have not achieved the absolute zero. That is what we call as the least possible temperature that is possible, okay. That is what we call as least possible temperature. It means the temperature, as what just now told, okay, as just someone has told that, sir, minus degree is not possible, but minus degree Celsius, minus degree Fahrenheit possible, but we can never go beyond minus 0 Kelvin, okay. Means below the 0 Kelvin it is not possible. 0 Kelvin is the final limit in the temperature, okay. The temperature could be more than 100, 200, 300,000, 2,000, 5,000 also, but absolute zero, yes, good question. What is absolute zero? Absolute zero is the least possible temperature, okay. Absolute zero is the least possible temperature. Got it? It is the least possible temperature. There is one more question as why we cannot go beyond 0 Kelvin or absolute zero. There is a reason for that, okay. The temperature, it means, usually in the molecule level, if I want to explain, try to understand this, okay. In the molecule level, if I want to explain, imagine I am also made up of the molecules or atoms now, and the molecules, yes, that's what others, good, right? Because after that there is no energy there, right? Yes. And one more way of explaining that one is, if I'm made up of, okay, imagine I'm made up of the molecules or the atoms at this temperature. We consider room temperature 25 degrees Celsius, even though it is more or less. So understand that at that temperature, the molecules and the atoms inside my body are vibrating or rotating, okay. So it may be moving like this, got it? It may be moving like this. So as you go below and below temperature, low and low, minus 100, minus 200, minus 250 degree Celsius, okay, minus degree I'm going now from 0 to 250, minus 100, minus 200, minus 250, minus 270, or if you reach to minus 273 degrees Celsius or 0 Kelvin, I'm telling once again, if you reach minus 273.15 or 0 Kelvin, now all the molecules in my body or all the molecule in this pen also, what happens is they will stop vibrating. They will become still, okay. They will become still. It means all the vibration, molecules, motion, everything is stopped now, okay. At this temperature, everything is stopped. There is no movement at all. I cannot, not even thinking about moving myself. I'm telling even the molecular level, where even now, okay, you cannot see, you cannot feel, but the atoms inside me are vibrating or moving like this, okay. That will also be stopped. I'm not telling about my movement, even the molecular level, the molecules stop vibrating or even rotating, okay. So that is why you cannot go beyond that, okay. It is just like you cannot go beyond zero velocity, okay. You cannot go beyond zero velocity. Can you move with minus 1 kilometer per hour? No. So zero is the least one, right? Zero is the least one. You cannot go beyond that speed. Similarly, molecule cannot go beyond zero vibration. So that's why it is considered as that is the least possible temperature, or that is the least possible or least or the last point. You cannot go beyond that. So therefore it is considered as the absolute zero, where all the molecular level vibration, motion, everything stops. So that's why it is called as 0 Kelvin. And the question, yes, even time does not exist or stops After that, about time, I cannot tell exactly, but even yes, even you can consider time will be moving, but motion will be stopped. Okay, every motion will be stopped here. Is it achievable in the future? Maybe. Who knows about that, right? We have reached to close to 0 Kelvin, but we are not reached to 0 Kelvin yet. And also you can get almost close value to this one in the space. Okay, in the space we can get the close value again to that one, and we have achieved in the laboratory also the value which is close to 0 Kelvin, but we have not yet achieved the 0 Kelvin. Hope so in the future we may achieve it. Okay, so okay, let's come to the point now. Okay, yeah. Let me explain this now. What is a triple point now? You know the triple point. You take ice now. Okay, you take ice now. You heat it. Okay, you heat it. Slowly, it will turn into a liquid now. You take the liquid at 100 degrees Celsius. Sorry, at 0 degrees Celsius, it turns into liquid. You take the liquid now and start heating it. At 100 degrees Celsius, it will be starting boiling. Right? You have experienced that one. That is what we call as a melting point and boiling point of water. Okay, then what is the triple point now? Triple point is a point where all the solid, liquid and gas exist all together. Okay, all together. So that's a different, or it's a kind of a different type of point where you take the ice, you change a small condition, light little heat it, it may turn into liquid or immediately gas only. Or you take the gas, okay, the gaseous water, just change the pressure of that one or temperature of that one, immediately it can be turned to solid, or immediately the solid can be turned into liquid. It's a special point. Okay, it's a special point. Understand how it could be now, right? It's a point. It's actually, if you draw in the graphical type, it is like this. In the graph it comes out to be like this. See, it's almost like this triple point. You know, it exists as a solid like this in this point. See here, it exists as a solid here. The water exists as a liquid, or the water exists as a gas. For example, imagine this is the normal pressure that is what we call as a 1 atmospheric pressure. Okay, this is 0 degrees Celsius. So if you start heating it, okay, up to this point, sorry, this is solid. Okay, this is solid, this is liquid, and this is gas. Okay, see here, as minus 250 degrees is below 0 degrees Celsius. Yes. See, if you start heating it, okay, if you start heating it, it will turn into gas. Okay, it was solid at this temperature. Now after crossing 0 degrees Celsius, it has reached to the liquid state. At 100 degrees Celsius, it has reached to the gaseous state. But triple point is a point, you can see the triple point is a point, just by changing something, the solid could be turned gas directly, the gas could be turned liquid directly, liquid could be turned solid directly without changing that much. Okay, immediate. Okay, if you see the YouTube, you can get to know the video of this one. Okay, you can see the triple point, just type it as triple point, you'll see the video where you see all the three, solid, liquid, gas, exist at equilibrium. Equilibrium means you could achieve anything within fraction of second. But in real life it is not like that. In real life what we see is, if you want to convert a solid into liquid or to gas, you take lot of time, lot of heat is required. But at triple point, immediate, just change a fraction, in fraction of second you can turn a solid into gas, gas into liquid. So that is what we call the triple point. It's almost close to the melting point, and it is taken as around 273. Okay, so now if you want to understand now, as I told you in the Kelvin scale, that at 273.15, the degree Celsius measures as 0 degrees Celsius. At 273 Kelvin, the degree Celsius measures as 0 degree, because almost melting point means what now? Melting point means 0 degrees Celsius, and in the Kelvin scale, it is measured as 273 Kelvin. So therefore, what's the relation now? The 0 degrees Celsius is measured as 273. Then what would be the 0 Kelvin measures as? That would measure as minus 273.15 degrees Celsius is measured as 0 Kelvin. In that case, then what's the relation now? This is the for the value, but if you want to calculate, or if you want to convert one from the other, it would be like this, as degree Celsius will be equal to, okay, degree Celsius will be equal to, or Kelvin, in terms of the Kelvin, if I want to write, Kelvin will be equal to degree Celsius plus 273. Okay, 273. For example, if I want to calculate, or you can write it as 273.15 only. So for 0 degree Celsius, okay, for 0 degree Celsius, you know the Kelvin value? Kelvin would be, okay, Kelvin would be, see, for 0 degree Celsius, Kelvin would be, Kelvin equal to 0 plus 273.15, or Kelvin equal to 273.15. So, and also after this you have to write K. So what it tells here is, uh, for 0 degree Celsius, Kelvin case measure 273 value. Okay. Yes, Prajwal. Good. Yes, Vinata. I hope this is clear. This is related to the temperature scale, and there are some points. Okay, there are some points that I can read out, and I'll provide you the notes. So first point is unit of temperature. Even though there are three way of measuring, unit is Kelvin only. Okay, Kelvin is the unit. And negative value of degree Celsius and degree Fahrenheit is possible, but Kelvin never goes beyond 0. So negative value is not possible. And you can measure, and it is for every 1 degree change in the degree Celsius, there is 1 degree change in the Kelvin. Okay, they are directly related. For every 1 degree change in the degree Celsius, there is 1 degree, 1 Kelvin change in the Kelvin scale. Okay. Then 0 degree Celsius is also called as a triple point. Namita, that's what I told you. It is almost close to that. Okay. 0 degree Celsius is not exactly the triple point. Okay. Yes, Pawan, I'll provide you. Almost close to that only. That's what I considered. Almost close to 0 degree, you get the triple point. Okay. But not exactly. Almost close. Others, just search in the YouTube once. Okay, you'll come to know. Just search in the, it appears as normal only, normal water only. At a triple point, it will appear as a normal water only. But only thing is that normal water you can convert into gas or solid immediately. Fraction of second you can turn it to solid. Immediately you can turn it as a gas. So that's the special thing about the triple point. If you're not getting that one, message me. I'll tell you the link. Okay. I'll give the notes, Ganesh, and also one more person also asked about the notes. I'll provide you the notes, but not now. Just at least wait for 1 week, okay? After 1 week, I'll provide the notes. Immediately providing notes for a very small would not be helpful. I will provide you the notes. Don't worry at all, okay? So in that case, the time is, we have exceeded the time. I will close this, okay? I will close this now. I'll end this one. You can get the video again in the YouTube, and I'll provide all the detailed notes about this one. Don't worry at all. All the books, you can refer the NCERT now, okay? For time being, you can refer the NCERT, and from college, if it is provided, you can refer that notes. And also I will provide you the notes so that you can refer that also, okay? I'll make sure that every week, at least once in every week, I'll provide you the notes. Yeah, I'll send in the WhatsApp group. Don't worry, Vijay. I'll send in the WhatsApp group in the PDF form. Yes, you are welcome. That book and all you should ask in the college only. I don't know, because every time it used to be given very early only, but now because of the corona and all, you know, there's a problem. Lot of it will be provided. Don't worry. Okay. In that case, we'll see tomorrow. We'll deal with some other things now. Okay. Thank you. Yes, you're welcome, everyone. Okay, you're welcome. I'm going to end it. Yes, yes. You're welcome. Yes, bro. Okay, I'm ending this now. I'll wait for 30 seconds. Okay. Thank you, Akshay. Thank you so much. I'll wait for 30 seconds, and if anything you want to tell, you can tell. Thank you, Mansa. Yes, definitely I'll put the video in the YouTube. I'll make sure that today only this video will be put in the group, YouTube. So I'll wait again for 30 seconds. If anything you want to tell, you can tell, or if anything you want to ask, you can ask. Otherwise, I'll close the video. Okay, tomorrow, Rohit, I'll tell about the plasma state tomorrow. States of matter, or we'll discuss. There is a chapter called States of Matter, the 5th chapter in the first year only. There also we can discuss, but plasma state is not that required. Okay, it exists only in the extreme condition. So don't worry about that. Still, I will tell you. Sure, sure, Vasant, I'll upload. I don't know, Pawan, but I hope by next month it may be started. Shraddha, if you message me personally about what is that sum, I don't remember now. What is that sum that I given? I can explain. I can make a video. I can send it in the group or in YouTube only. I can upload. I don't remember exactly which one you're talking about. Message me personally or in the group only. You can message that these are the sums. Please explain. Then I will explain. Okay. About lesson wise marks and all, I'll tell you tomorrow. Okay. I'll tell you tomorrow. When everyone is there, I'll tell you tomorrow. Okay. Yes, we'll think about it. Okay. About chemistry, I'll try to upload as soon as possible. But others, I don't know, but I'll tell them. We didn't get the NCERT book from college. I think NCERT book won't be provided by the college. Just make sure you ask in the college office. If they provide book, they will be providing a different book. I think NCERT you should buy it. Okay. You just make sure. Just call to the college and just make sure whether it is provided by the college or not. It's actually first chapter, very important chapter. That's why I'm taking little extra time here. Slowly I'm going, but more than 15 hours is required for the completion. It contains so many new concepts. A lot of problems are there, but I'll make sure to complete very early. Yeah, you can leave. I'm waiting for those who want to talk or want to communicate. Ruchita, you can get ready for the next class. Application of triple point means it's a measurement, just a measurement that is done for every solid. We measure the triple point because if you know the triple point, we can have the usage like when it can be converted directly from solid to liquid, when it can be used for the, because if you know dry ice is something which is directly converted from solid to gas. So all those things, simple measurement usage, will be using the triple point, but it's not exactly. Okay, if you want more, many are asking about the triple point. I'll do something. I'll make sure that how I can explain in a more better way tomorrow. Okay. Almost same. Okay. You can use the old NCERT book. So don't worry about that. You can use it. In that case, I'll end it now. Okay. We'll meet tomorrow. Thank you. Melting point of Kelvin. Melting point measured in Kelvin, and it is a 273 Kelvin. Melting point is measured in Kelvin, and if it is measured, it will be 273 Kelvin.